everyone. I am so excited to be here. I currently live in New York City, and this is my first time in Toronto. So when SwiftUI was announced, we were all really excited. And I was extremely curious to see whether it could handle a more complex UI component. In order to see the limits of SwiftUI, I decided to translate a complex custom UI component that I built at Compass into SwiftUI. It's called a range seek slider. And don't worry, if you haven't heard of it, I have lots of demos showing you what it looks like. So the actual code that I wrote is only used in real estate agent-facing features. Compass is a real estate company, and so I can't demo it. But my range seek slider is based on an open source project that has a very similar UI and supports many more customizations than we needed at Compass. Let's see. So this is the open source project, and this is all that you can do with it. The Compass range seek slider is 360 lines of code, and it also has a view model that's 120 lines of code. This project seemed overwhelming, since the range seek slider I wrote in UIKit took several weeks to get right. It included complex gesture code and core graphics code and a lot of math. So my first step was to simplify the existing code to focus on the essential ideas I wanted to explore in SwiftUI. Those are shapes and gestures. I wanted to break down this bigger project into smaller milestones. And even for extremely simple cases that I could do in my sleep in UIKit, I wanted to make sure the little details were right. This is similar to what I've been working with my climbing trainer on. I started seeing a climbing trainer a couple months ago, and if anyone's into bouldering, I currently climb at V2 is my limit. That's kind of beginner intermediate. It's really not a super hardcore, climbing skill. And I started working with a trainer because I wanted to level up and get more into the intermediate level. So one thing that surprised me is that in our climbing sessions, we don't do climbs that are at my absolute limit. We've never done a V2 climb in one of our sessions. We actually do V0 climbs, which are climbs that I can pretty much finish anytime I attempt them. I see a new V0 at any climbing gym in the world, I can do it. I have to do these easy climbs while using all the right technique. He wants to see me twist my hips. He wants to see me plan my route ahead of time. And he wants me to stick to my plan even if it feels awkward. He doesn't want me to pull with my arms. I need to work on jumping down from higher and higher parts of the wall. I need to practice falling safely so that if I do accidentally slip and fall on a really hardcore climb, I won't injure myself. So I have to do all these little details right before my trainer will even let me do a V0 climb. So let's apply that same approach to my project. Let's use the native slider. So I had some goals. I wanted to have the correct padding on the left and right side, and I wanted formatted text that displayed the selected value. This is what it looks like in SwiftUI. And even this very simple example made me grapple with some deeper concepts in SwiftUI. I came across the issue of dependency injection with views. I realized in order to get my numbers to be formatted correctly, I needed to initialize my slider with a number formatter that we pass in. In the real Compass use case, we have sliders that display price filters, and we also have sliders that display square feet or lot size, and they needed to be formatted differently. This code didn't compile. So, like any good engineer, I went around Googling for some answers. Turns out someone else ran into the exact same issue, and they posted in the Swift forums. Joe Groff, who's a senior Swift compiler engineer at Apple, responded. So he's like, this, you shouldn't really be doing this. Like, this isn't what the state property wrapper is intended for. And he had some good reasons. Okay, so he said that the state property wrapper is primarily intended for small-scale UI state. Okay, so I updated my code to not use the state property wrapper, and everything worked. We can see here that I have two sliders. So at Compass, we work with some pretty big real estate deals. So, I'm cruising around for $5 million properties. No big deal. Oh, what about lot size? I think, 20,000. That sounds nice to me. So this was my native slider. As we can see, it only has one handle. So it doesn't quite do what my custom range-seek slider did. So if you've been looking at SwiftUI, you might have noticed all these different property wrappers. We have bindable object, we have environment object, we have state, and you might have gotten very excited and you want to use them for everything. In this case, bindable object isn't a good fit for the number formatter because it isn't going to change once you initialize the slider. And it doesn't need to be observed by any other views. Only my slider needs to access this number formatter. Another thing you might have noticed in my code example are CG floats. You might wonder, I thought we were breaking from tradition and leaving behind old baggage that didn't serve us well. Well, if you wonder that, you are not alone. Nick Lockwood posted on Twitter this exact same question, and he received a lot of responses, including from none other than Joe Groff. So if you want to tweet out questions on Twitter, who knows, you might get a beautiful and very helpful response from Joe Groff. So I am not expert on these topics he mentioned, but if you want to learn more about why CG float is still used in SwiftUI and why we can't just get rid of it, you can look at this Twitter thread here for a lot of great information on the topic. Okay, I used the native slider. I got something working and it looked pretty good, if I do say so myself. So the next step was to make a project with simple gestures. I just wanted to figure out how gestures worked in SwiftUI. In order to tell you about how wonderful it is to use gestures in SwiftUI, I need to explain to you how terrible it is to do complex sequence gestures in UIKit. So if you subclass a UI control class, you can override begin tracking, continue tracking, and end tracking to handle touch events. In this case, we had some complicated calculations around determining whether the touch was on the left or the right handle of the slider. And if it's on neither, then we fail the gesture. We return false. This means that if the user touches the UI control again, we will call begin tracking again, and it will be treated as a new gesture rather than the continuation of an existing one. Okay, so if the first touch is valid, then in the next touch we'll hit the continue tracking function. We have a lot of code here to determine the selected value based on the touch and update the UI of the slider accordingly. And then once the user stops their gesture, we reset the state. And then, if the UI control is touched again, we'll start at begin tracking again. So gestures are handled quite differently in SwiftUI, and it's really nice to use. So this is from the SwiftUI documentation. SwiftUI doesn't evoke the updating callback when the user ends or cancels a gesture. Instead, the gesture state property automatically resets the state back to its initial value. SwiftUI only invokes the onEnded callback when the gesture succeeds. So this is an example of a sequence gesture from the SwiftUI documentation. So what you're telling SwiftUI is that this gesture needs to be a long press and then a drag. And you don't have to write any code to handle the failure cases, say if someone does a drag first. So this was extremely encouraging and exciting. But after all of these milestones, I was stuck. The next step, the UISlider UI without the gestures, seemed really far away. Whenever I get stuck while learning a new paradigm, I think it's important to take a step back and improve my conceptual understanding. If all I do is play around and try to figure things out on my own, I will waste a lot of time going down dead ends, and I'll become frustrated and maybe even give up learning the new topic. Understanding the motivation for a framework and its underlying implementation details will help me more efficiently figure out the next right step. I found this blog post from Cocoa with Love extremely helpful. One key thing to do when learning a new paradigm is to move from how do I do X and Y to what's the new X. I'll share some examples to make this more concrete. So when I was working on this project, I was thinking, where is UI control? Like, where is it? Where's begin tracking, continue tracking, and end tracking? I have to override them in my new class, right? So first off, there's no more UI control. You have to use a view. And given the way gestures work in SwiftUI, you call this updating on change and on end functions on the gesture itself, instead of overriding any functions on our class. After taking some time to improve my conceptual understanding, I felt ready to take on the next step. This WWDC video from this year was extremely helpful for me. And one of the key points is that we no longer have a UI kit and core graphics separation. Everything is a view now. So this is what the UISlider without any gestures looks like. Basically, we have an H stack, and within it, we have a circle, rectangle, and circle. One thing that I did was I set the Z index of both those circles to be 1 so that they appear in front of the line. And you see the CG floats, but otherwise, this ended up being fairly straightforward. And this is what it looks like. So, after doing all these intermediate steps, the final step was to add the gestures. This was going to be the culmination of all my hard work and all my milestones. And I'll just say that the code for this does not fit on a single slide. So let us start. This is the first part. So one of the things that was core to this project is that I didn't want to just get it to work. I wanted to apply those same principles I described earlier about how I approached my rock climbing. I wanted it to look, as close as possible to what we do in production. I wanted to be able to, have customized min and max values and customized step. And I wanted to be able to handle that like we handle it in the production app. So these are all the variables. And this is the first gesture. So one of the key differences here is that we're initializing this gesture. We're saying this is a drag gesture, and in the onChanged, we put what we want to do. And we have another gesture that's the right handle drag gesture. One interesting thing I noticed, you'll see the negative signs here. So the like the position it gives you of the location of the touch. If you're moving here, it's positive, and if you're moving from here, it's negative. So this is what I did to handle it. And basically what the selected min and max value is doing is it's basically translating the position of the handle on the line. Like if it's halfway, if it's 3/4 of the way, translating that into what the correct selected value is. And this is also similar to what we're doing in the production app. And this is our old friend. Now we have our H stack embedded in a V stack because I want to display the selected min and max values. So this was the final result. Yeah. And I'm not going to lie, this took like, I don't know how many hours, but it was probably over 10 or 20 hours of work. So it was like, I think this is also a great example going along the themes of what everyone else was bringing up in their talks is it's easy to look at the end of your hard work or to, write a bunch of blog posts, put on YouTube videos. If you're not dazzled by the results, or you think, oh, like this wasn't that hard. What is it? This is just one component. You need to, embrace the fact that actually was a lot of work. And if you keep going, I can build on this. And I don't have that intimidation that I had when I first started this project. I have all these ideas for how I can make this more and more like the production version of the component. And I don't feel intimidated to do those. So this was the previous UI kit code. We had to determine the X position of the handle, and the SwiftUI version takes about half as much code. Here are some comparisons of the lines of code. So to determine which handle was being dragged, it was 20 lines of code in UIKit, and in SwiftUI, it is 0 lines of code. To set the position, the X position of the handle during the drag gesture, it was 14 lines of code in UIKit, and in SwiftUI, it was 6 lines of code. As I improved upon my component, I wanted to continuously refine it and make any improvements that I thought would be important. I changed the minimum distance of the gestures to 1 so that they responded immediately. I guarded against the touch location to make sure the handles were always on the line and didn't go too far to the left, too far to the right. And the formatted text displays the min and max values. But there's actually so much more I could do. In the UIKit code, I have complicated logic so that when the handles overlap, we actually determine kind of the best behavior when someone, drags. We basically, what we do is we determine where they're dragging, and that handle is the one that starts dragging. So there's even more things that I could translate into SwiftUI just from this component. So now that I've reached the end of my example, I wanted to cover 2 important themes. And the first is your knowledge portfolio. This is a chapter in the classic book, The Pragmatic Programmer. You can think of your knowledge portfolio like an investment portfolio. Learning about new technologies that aren't popular yet carries a higher risk that the knowledge will become irrelevant, like Microsoft Silverlight. I don't know. But it's a higher reward that you get if it ends up blowing up and becoming this incredibly popular technology. You'll be the one with the head start, getting the jobs and being the expert. So I have a question. How many of y'all started iOS development when the first iPhone came out? So it's a small but very exclusive and mighty group. These folks took a risk on something new, and they were greatly rewarded for it. Technologies that are more established, like iOS development now, carry a lower risk, but also a lower reward since a lot more people have the skills now. Let me bring it back to SwiftUI and combine. Some brave folks in the iOS community adopted reactive programming and declarative UI programming before this year, even writing their own frameworks and libraries for it. If you look up declarative programming, you will see Facebook released declarative UI frameworks for both Android and iOS. Nick Lockwood has a declarative UI framework for iOS. If you look at Flutter, the cross-platform mobile framework from Google, if you look at React, you'll see that declarative UI programming has actually been around for a while. And these brave folks who adopted it without, that formal support from Apple carried a bigger risk that these technologies wouldn't be adopted as widely in iOS. But they got a bigger reward that they'd be the expert teaching others if Apple adopted it. So I don't want to pretend like I'm one of these early adopters. I mean, I guess I am, but I wasn't an early adopter, earlier this year. I'm a recent early adopter. I didn't do reactive programming or know anything about declarative UI frameworks until I joined Compass 4 months ago. The folks that I work with love to learn from other platforms and stay on the cutting edge. And this was actually a little uncomfortable for me during my interview process when they mentioned Flutter, and I was like, what is this? I'm like, I'm an iOS developer. That's what I want to do. But their approach has really influenced me, and it's inspired me to rebalance my knowledge portfolio. So now I have some more risky investments along with the more stable ones. This is another topic that is close to my heart. And it's covered in much more detail in the Cocoa with Love blog post. At this point, Android, web, and even Windows all open source their application frameworks. And I know from working with SwiftUI that big declarative UI frameworks handle so much more for you. And right now, a lot of us are, playing around, seeing what works, but it's completely different if you have an open source framework where you can really look at the source code. And I think it's especially important for declarative UI frameworks like SwiftUI. So if you want to follow me, I'm Veronica. My favorite emoji is metal. And thank you so much for having me in Toronto.